Properties of real numbers. So we're going to be looking at like transitive property, reflexive property, the stuff that you've seen. So reflexive property mathematically simply says A equals A. Okay, so whenever you get to a final answer and maybe you're proving something, you get like 7 equals 7, that is a true statement. 7 equals 7. Symmetric property just tells us that if A equals B, then B equals A. When would you ever use that if you wanted to do what? I mean, it doesn't make sense in a sense until maybe you apply it later in the year. But if you wanted to just switch the equation so that you had all the variables on one side than the other, you could always just flip the equation around, right? You could also move them over by subtracting and adding. But that's all the symmetric property is going to tell us there. Transitive property, also known as the chain rule. Easy example to remember this always is to think about something like height. If one person, let's see, I am relatively short. Niall, you're taller than me probably. How tall are you, Niall? Yeah, you're taller than most people. So Niall is taller than Ryan, and Ryan is taller than Nina. I'm guessing just by looking, I don't know. So you would say that Niall must be also taller than Nina, right? The transitive property tells us that if something is equal to another, and the other thing is equal to the other, they're all equal, or if something is greater than another, which is greater than the next, then the first is greater than the third. Okay, so transitive, just think about like a chain rule that time. Addition property of equality just means that if you can add the same number to both sides of the equation, it is still true. Why might you use that? When you're solving normal equations, okay? You have to use that all the time. You might not realize it, but you do. And the same thing goes for multiplication. So if you have A equals B, then AC equals BC because you're multiplying both sides by the constant C. All right, some field properties of real numbers that you've heard of before. Commutative. How do you remember commutative?
Sort of like something moving.
A little louder, because I can't hear you anymore here.
Commute is something moving.
To commute is something moving, okay. So, what are you saying for here? Give me more.
For a computer, it's sort of like
I like the idea of moving, right? Because when you commute to work, you go to work and then you come back, or commute to school, you go to school, come back. How does it relate to the commutative property?
There's the commutative of addition and multiplication. So if you're multiplying, you can switch, or if you're adding, you can switch.
Yeah, so think about switching. So because you can switch them, it's like, all right, well, I go to school this way in the morning. I walk to school, I take this path. I go up like 5 or 6 blocks and over from the subway. And on the way home, you switch it. You go the other direction, right? So think about that you're switching the two, you're commuting. How about associative? How do you remember associative? This is an easy one to remember.
well, the two variables in the parentheses, they're friends, and they exclude C. Then on the other side, B and C are talking to each other.
Yeah, exactly. The grouping of everything. How things are grouped with parentheses. The people you associate with, right? Associate meaning deal with or talk to, or your friends, the group of friends you hang out with. So I remember that the grouping has to do with who you associate with, or the associative property. Okay, and again, it's of addition and multiplication. Inverse properties, we have the additive inverse, okay, where anything plus its negative is 0, and the multiplicative inverse, where anything times its reciprocal is 1. Okay, again, we call them opposites for addition, we call them reciprocals for multiplication. Identity elements. Have you heard the term identity element before? Okay, 0 is the identity element for addition because it doesn't change it. It's identical. If I add 0 to anything, it's itself still. If I multiply anything by 1, it's itself still. So the identity elements are 0 and 1 for addition and multiplication respectively. And finally, distributive property. What do you have to remember to do when you have distributive property every time? How do you distribute? What do you do?
You multiply the number outside of the parentheses to each number inside.
Good. To each term inside. Very good. So you multiply the outside to each term inside. Now, be careful, people. Ready? This. Oops. This implores that you use distributive. You could just add these together and get 10 and multiply by 2 is 20. Or you could say 2 times 4 is 8. 2 times 6 is 12. 8 and 12 is still 20. Agreed? But this is not using the distributive. You cannot distribute this. Distributive only works or only used when there are two terms. This itself is a term. The product 4 times 6 is a term. 4 is a term when it's added. 6 is its own term when it's added. So we have to remember that. Okay, you're not distributing when you have multiplication. So many people do that, and it's a common mistake I see all the time. Only when there's addition or subtraction that separates these numbers into two different terms. Again, these together are considered one term when there's a product. So let's go ahead and simplify this, please. Let's go ahead and simplify this. I need to use my associative property here. Okay, it's kind of like associative and commutative really at the same time. Multiply the variables in this problem, right? There are different variables. You cannot multiply them. So you leave them alone. But the numbers, you can move them all out of the parentheses because the associative property tells us we can reorder the parentheses. I don't even put parentheses at the end. I don't need them because everything is multiplying. Whenever everything is multiplying, drop all your parentheses. Okay, they're not necessary. Is that clear? Assuming there's no power, obviously, outside the parentheses. All right. Now, we're starting with the first line, and we're going through the steps to simplify. And I want you to give me the property that is used to simplify during each step. Okay, so how do I get to the second, or the part A from the original? How do I go from here to here? What property? Distributive, right? What are you distributing? What's the number you're distributing?
You distribute 2 to y and 2 to 1.
Yeah, we're distributing this 2 to both of those. That gives us line A. So to get to line A, we write distributive next to it. Okay, that's how we got to line A. It was distributive. How do I get from line A to line B? Luca. Identity. How do you know it's identity? What's the only difference in those two lines, Luca?
The y is 1.
Yeah. If you multiply anything by 1, it's itself. So the identity property tells us we can put the 1 in front of it. Okay, which you probably wouldn't really do. Okay, this is like the slowest version ever of simplification. It's just I'm overemphasizing each step. Okay, you wouldn't actually show every single step here. From line B to line C. What's the change from line B to line C in this problem, Nick? Line B to line C.
Switch the parentheses.
Yeah, good. And that means what? Yeah, there it is. Good. Remember, parentheses is grouping, right? Is grouping. And grouping is parentheses, or is grouping is like your friends, or you're with, or you associate with. From line C to line D. Line C to line D. Nina, what do you got? It's a little tricky, Nina. It's kind of the opposite of one of our properties. I'll give you a hint. It's not one of our properties, obviously. It's the opposite of one of our properties. Make believe you didn't know the properties. What are you doing from line C to line D? You're taking out this variable, right? What do you call that? What's the term for it that you've learned? When you take something out of an expression. What is it? Not eliminating. I get what you're saying eliminating because it's getting rid of it, but it's still there.
Is it the opposite of distributive?
It is the opposite of distributive. It's like you're factoring something out. Remember how if you have a GCF, you could factor out in front? You're really taking a GCF out, right, of the y. So it's like the distributive, but it's the opposite. So we'll write distributive for this one. Okay, it is the distributive property, but it's in reverse. That's all it is. Think about it. How would you get back from line D to line C? You would have to distribute this y right here. You'd have to distribute the y. And finally, the last line. Finally, the last line. This is not one of our obvious properties. This is something else that we talked about. When you replace an expression with an equivalent expression, you are doing what? Okay, the word replacement is fine. We called it something else a minute ago.
Oh, substitution.
Substitution. Okay, replacement's fine. But substitution, property of equality, not subtraction, substitution. Don't abbreviate that too much. Okay, substitution property. All right. How are we doing so far? Is this okay? Do I need to stop and slow down a little? Am I going at a good pace? Yeah? All right, if you think it's too fast, let me know. I want to keep... There's a term called closure. And it's not if you break up with your boyfriend or girlfriend, you get some closure and you don't want to talk to them anymore. Not a funny joke at all, really? Nick laughed. All right, thank you. When you become a senior, you'll get closure and all that and whatever. All right, closure. So a set of numbers S that is closed under a specific operation if that operation results in another member in that set. That seems like another language. Nobody has any idea what that means if you just look at it real quick. So let's discuss what closure is with an example. Okay, to determine whether the set S is closed under the following operations. Here's what it means. Take any of the values in the set S, which goes on infinitely, and perform an operation. If the result is another member of the set, it's closed. So what's 3 times 6? 18. Is 18 in this set?
Yes.
It surely is. Because this set is the multiples of 3, isn't it? So 3 times 6 is 18, so far it's good. Pick other numbers in the set. Pick bigger numbers in the set. 69 times what? Times 9. Multiply those on your calculator. Go. Do 69 times 9 on your calculator. You're not going to probably do that one in your head, right? What do you get as a result? It's me. Louder. 621. Is that divisible by 3? You divide by 3. You might know the answer, I'm just telling you to do it. It most definitely is, right? So that is in this set. It's a multiple of 3. So if every time you multiply, you get a result that's in the set, it means it's closed under the operation of multiplication. So the answer to part A is yes. It is closed under multiplication. Is that clear? Now, it's tough because you really need to try everything. So you need to also pick up on patterns. And the pattern here is what? What's the pattern here? Anybody pick up on it yet? They're all multiples of 3, good. So the result is always going to also be a... Yeah, because if you think about it, ready? I'm going to write the set like this. That's what the set really is, right? 3 times, that's a time, I should have put a times there, sorry. 3 times 1 is the first number. This is really 3 times 2. This is really 3 times 3. 12 is really 3 times 4. So what happens is, when you multiply any of these two values, you're always multiplying 3's, right? There's always a 3 in there somewhere. 3's are the factors. So the result always has to have a factor of 3. So all results are going to be closed under multiplication. How about addition? How about addition? Anybody try addition? Luca?
Yes.
Why is it yes? Give me some examples.
Well, because, 3 plus 6 equals 9, no matter what, you're still going up the multiples of 3, so it's still always going to be equal.
Yeah, when you're adding multiples of 3, you still end up with a multiple of 3. Try any of them, right? 3 plus 6, well, that equals 9. 3 plus 15, that's a multiple of 3, well, that equals 18. Which makes sense, right? Because really, 3 plus 15 is like having 6 3's here. That's a multiple of 3, giving you 18. And how about division? How about division?
It's not.
Why is it not? Because I thought it was at first. Is it 9 divided by 3, 3? So it looks like it works. 9 over 3 is 3. That seems to work. But 18 divided by 9 is 2. Is 2 in the set? So it's not closed. So if you could find one example... Yeah, another example. There you go. 6 divided by 3 is also 2. 18 divided by 9 is 2. Or how about this? What's 3 divided by 9? Isn't that just 1/3? Is 1/3 in the set? No, it's not. So if you can find one example to prove that the operation doesn't result in the same set, it's not closed. Okay, so the first two were closed. The third one was not closed. Was not closed. Are we clear? Okay? All right. All right. Let's see if I wanted to mention anything else at the end here. All right, now that's it. You have a lot of homework, guys. There's a good amount of stuff. So let's think about this so you're not going to be overwhelmed. Change that to multiples of 5, okay, for this section 1-3, so it's fewer problems. And change section 1-2 right here, okay, to multiples of 6. So numbers 18 for the last part here, right? Numbers 18, 24, 30, 36, and 42. It just reduces the amount of problems that you're going to be doing. And the other homework I gave you was 1, 2, right? What was the multiples of for 1, 2? Multiples of 3. Why don't you do multiples of 4 for that homework? So it's fewer. Okay? Just to cut down the problems a lot. Because you're going to have a lot of stuff to do then. Page 26, I just want you to read. Okay, there's going to be several times throughout the year that I'm going to say, just read this part. And whenever I give you a reading, one way I check that you read is just to give you a quiz real quick when you come in. I don't always do it. I may or may not do it tomorrow depending on our timing. Okay, but I really need you to read this stuff when I tell you. Don't just assume you're, oh, it's no big deal, it's just reading, it's math. Reading is important. Please do it. Okay? Any questions today? Again, I know this is review. Chapter 1 is a lot of review. Tomorrow, we're going to do sections 1, 4, and 5, and 6 all at one time. Section 1.4 is adding, and subtracting. Section 1.5 I think is multiplying and dividing. So it's like stuff you've seen. So I just want to go through some basic problems to get any issues out that may be apparent. Okay?